Hi guys, welcome welcome back to my YouTube channel, and today I'm up with the next video of top 150 interview questions of LeetCode. So let's get started with today's question. So today's question is a very popular question. It's maximum subarray. We are given an integer array nums. We have to find the subarray with largest sum and return its sum. So before moving further in this question, let's just figure out what a subarray means. What does it actually means? It is a non-empty sequence of elements within an array. Continuous contiguous non-empty sequence. It means in that uh, all the elements in continuity will will actually turn out to be a subsequence. So let's discuss the approach for the question and let's move further in the code uh, in in diving into the optimized solution for the same. So let's get started. Let me just jot down my example test case. So what I have right now is I have a nums array. I have -2, 1, -3, 4, -1, 2, 1, -5 and 4. And the expected output out of this array is 6 as of what I can remember. And this is the possible contiguous, basically this is the possible subarray which will actually result in this answer. That's what the question states. So just leave all the things aside. We have to find the subarray with the maximum sum in this question. So what we can actually do, a simple naive solution to it is just take two for loops starting from 1 till n minus 1 and another till I to n. Simply iterate over all of the loops, find out the maximum sum, store it in some variable after each and every iteration, and in this way you will get your maximum sum. That's what the intuitive approach comes to everyone's mind before just jumping to any other solution, right? And the time complexity of that approach turns out to be big O of n square, and space complexity as usual big O of 1, because we are not using any extra space in order to store our answers. That's what the intuition lies over here. So what we can simply do, we are just taking up one element, finding all the possible subarrays that we have after this, combining this element within that subarray. And if we are not able to find, just simply move towards the next, so on, and so forth. A, a very long story. But in an interview, if you'll start narrating this long story, the interviewer will not at all be happy. He or she will ask you to find out an optimal solution for the same. So the optimal solution for this problem exists using, we can find it out using the Cadence algorithm. Cadence algorithm. So what does this algorithm simply states? What is this algorithm all about? So let's just explore while searching on the Google. So what is Cadence algorithm? It is a dynamic programming technique which is used to find the maximum subarray sum within a given array of numbers. So as we can see from this statement that it is a dynamic programming technique, right? So when we are actually trying to do something like dynamic programming, so we are actually storing the previous result in something or the other, right? So in this case also, what we are actually going to do while utilizing Kadan's algorithm to solve this problem, we will simply store all of our we'll simply store our previous sums in some variable previous, and and after each and every after including all the previous sums, we will simply just compare with the given sum that we have, that is our final answer, or we can say the sum that we actually have. If my previous turns out to be greater than my sum, then I will simply update my sum, or else I will not update it. And there is one more constraint to this problem, because we are already having negative numbers. So there is a great possibility that our sum of subarrays can turn out to be negative. But there is a but that we have to find the maximum possible sum. So in order to find out the maximum possible sum, we need to make sure that our previous always lies between 0, it should be some positive number. It should be some positive number. So it means that our previous should be some positive integer, right? So so we need to make a check on previous as well while traversing in the loop, that whenever my previous sum turns out to be less than 0, we have to simply update it to 0. That's what the basic intuition of the Cadence algorithm is all about. So now let's just write some pseudocode for the same. So what I will do, I'll simply take a loop. I'll simply iterate from my 0 to n, 0 to n minus 1, and then I will simply, I've taken two variables, that is previous equal to 0 and sum initialized to int min, because I have to find the maximum possible sum. So what I will do, I'll simply add to my previous my nums of I, compare my previous with my sum, compare the maximum out of my previous and sum, update my sum at each and every point, and then check if my previous turns out to be less than 0. We have to simply update our previous to 0, and then at last we need to return the sum. This is the whole sort about the algorithm, and the time complexity for the Cadence algorithm turns out to be big O of n, and the space complexity turns out to be big O of 1, as we are only using one extra variable previous in order to store the running sum of the elements present in the nums, of all the numbers that are present in the nums. That's what we are only doing using this previous. So what I can actually say after doing this algorithm, that this algorithm is basically a fusion of dynamic programming. Why so? Because we are storing the running sum in some previous, and also it somewhat looks like sliding window also, because each and every time what we are actually doing, we are just shifting shifting our focus from one element to the other. Like whenever we have included our sum, if we are able to find the maximum at that point, we are just keeping it in our answer, and or else we are just moving forward. That's what we are doing, like sliding window. So it is um mix. It is so this algorithm on which we are working, which is Cadence algorithm, is a fusion of both sliding window as well as dynamic programming. So I think it sounds to be really clear. So let's move towards the code of this problem. So yeah, here's the code. It is also similar as the pseudocode which I've already discussed. So now let's just run the code. It works fine. Now let's submit the code and it works really well. So I hope guys if you've understood this question, please do hit the like and subscribe button. If subscribe if you're new to the channel, like if you watch my videos, and if you feel and I also request all of you to please motivate me by sharing by sharing the videos with your friends, and that's what I can say. And if you're a college student, then I also request you to please share the video links in the YouTube video links in your WhatsApp group so that it motivates me a lot. Uh, it motivates me a lot and also motivates much more in the inner depth of mind to make more videos like this. Thanks a lot, guys, and keep watching my videos.